This is Euclid Book 10, proposition number 36. Okay. Now, does that look familiar to you? That is a binomial equation. Okay? And now we're going to show you how to form a binomial equation. We're actually going to define it for you. Isn't that nice? If two rational straight lines commensurable in square only be added together, the whole is irrational, and let it be called binomial. For let two rational straight lines AB and BC, well, here's AB and here's BC, be commensurable in square only, and let them be added together. So we're going to add these two together. I say that the whole AC is, so we're going to say that this whole line here is irrational. For since AB is incommensurable in length with BC, for they are only commensurable in square, in other words, if you made a square out of this line AB and you made a square out of this line BC, they would be commensurable in square, but they are incommensurable in length. Okay? And as AB is to BC, now we're starting a ratio, so is the rectangle ABBC to the square on BC. Okay, so now we're going to make a rectangle. And it's going to have two sides AB and two sides BC. Okay? And that's going to be the top part of the other part of the ratio. And you probably sit there going, I'm confused. Okay. Okay. As AB is to BC, now we've made this rectangle, two sides of AB, two sides BC, and now we're going to make a square out of BC. All four sides of that square is going to be the length of BC. That is your ratio. Okay? Therefore, the rectangle ABBC is incommensurable with the square on BC. So this is incommensurable with this. And this is by Euclid Book 10, proposition number 11. But twice the rectangle ABBC. So in other words, you're going to take ABBC, you're going to find the area inside of it, you're going to multiply it by 2. Is commensurable with the rectangle ABBC. Okay. And this is by Euclid Book 10, proposition number 6. And the squares on AB and BC. Now you're going to make a square out of AB, and you're going to make a square out of BC. Those squares are commensurable with the square on BC. Okay. So the area of the square of this and the area of the square on this is equal to the area of the square on this. Well, not equal to, but it's commensurable with. Okay? For AB, BC are rational straight lines commensurable in square only. Okay? So these two lines are rational, but they're only commensurable in square. And this is by Euclid Book 10, proposition number 15. Therefore, twice the rectangle ABBC is incommensurable with the squares on AB and BC. So this rectangle is incommensurable with this square and this square. And this is by Euclid Book 10, proposition number 13. And componendo, twice the rectangle of ABBC together with the squares on ABBC, that is the square on AC. So in other words, if you add the area of this square and this square together, you're going to get the area of the square on AC. So you're going to take this AC here, you're going to make it into a square, and that area is going to be equal to this area plus this area. Got it. Now, so twice of this area plus this is incommensurable with the sum of the squares on A, B, and BC. Okay. Now, the square on AC is formed by Euclid Book 2, proposition number 4. But the incommensurable part is Euclid Book 10, proposition number 16. But the sum of the squares on A, B, and BC is rational. So if you add these two together, they're going to be rational. Okay? Therefore, the square on AC is irrational. So that AC is also irrational. Okay? So the square on AC is irrational, and also AC is irrational. And that's by Euclid Book 10, definition number 4. And now we're going to call line AC a binomial. And that is the definition of a binomial. Now you know. Alright. That should help you in your math classes. I will tell you more in a future video. Stay tuned.